Welcome to ePathshala lecture series on computer science. This particular topic is about data analytics. In today's session, we will be learning the following things. First, we will be understanding the fundamentals of data analytics, followed by what is the difference between data analytics and data mining. Then, we will be learning the basics behind big data and its impact on analytics. Later, we will be understanding the characteristics of big data and know about the applications of big data and analytics. So, initially to start with, let us define what is data analytics and then understand what exactly it is. Fundamentally, when we deal with respect to any data, all that we are trying to do is we are trying to analyze the data. But exactly speaking, what data is available across the globe? The data that is available across the globe is actually the raw data. So, what we are trying to do is we are trying to collect this raw data and then we are trying to analyze this raw data for various reasons. So, fundamentally data analytics is the science of examining raw data with the purpose of drawing conclusions about that information. Now, why we are saying this as a raw data? This is one important question that may arise. The data that actually we are encountering in the real world are raw facts. These raw facts sometimes may not be clean or quality in nature. What exactly you mean by not clean or not quality is the data that is actually captured from the real world may contain lot of inconsistencies, may be in different data sources, may be available in different data structures or formats, and few of the data might be missing. That is the reason why we call this as a not quality or say a data that is not clean. So, we are dealing with say a raw data that is not clean as well as not quality in terms of its quality. That is why we are actually calling it as raw data. So, we take any raw data and when we want to do some analysis on the raw data, initially we need to do some level of processing on the data. Why do we require this processing is when we do processing on the data, we actually are trying to eliminate the anomalies or say the unclean information or the unclean fact that is available in the data. Sometimes even a missing information will be there. This missing information will always reduce the quality of the data. So, in order to improvise the quality of the data and hence to derive quality knowledge from the data, we need to do pre-processing. So, data analytics is all about examining raw data with the purpose of drawing conclusions about that information. This data analytics can be broadly divided into three. First, it is exploratory data analysis. What exactly you mean by exploratory data analysis is new features in the data are discovered. New features are certain features that are not already known to the real world or certain features that are hidden in the data. So, that is what we call as new features. So, we will be analyzing the data for the purpose of exploring new features that might help in decision making process. This is what you call as exploratory data analysis, EDA. In short, it is called as EDA. The second type is confirmatory data analysis. Confirmatory data analysis is we actually try to prove certain things, what it may be. There may be a pattern that is available in the data and we will be trying to prove it. Now, how exactly we prove is we will be proposing a hypothesis. The hypothesis will talk about say a pattern and we will be proving whether the hypothesis is true or wrong or false. So, this is what you mean by confirmatory data analysis. The third type of data analysis is qualitative data analysis. This is fundamentally drawing conclusions from non-numerical data. So, these are the three types of data analysis that we can do and all these three things put together is only called as data analytics. But till date there is no exact definition for data analytics. Data analytics actually differ from one person to another person in terms of the scope, in terms of the analysis that we are performing as well as in terms of the data that we are actually dealing with. We will discuss about how it is different from data mining later. So, in this slide we will come to know how exactly data analytics is different from data mining. Now, as I already mentioned, data analytics is distinguished from data mining by the scope, purpose and focus of the analysis. For example, we may be looking in for an analysis that must highlight certain factor or that must highlight certain pattern that is available in the data set. So, our scope is restricted to that particular pattern. So, from a minor perspective, we will have to do this analysis with respect to this scope, that is we need to keep the scope in our mind and do the analysis accordingly. Sometimes we will be working towards a purpose. The purpose may be identifying a pattern for certain decision making process. So, with that particular purpose in our mind, we will be doing the analysis. Hence, data analytics differs from one individual to another individual as well as from one tool to another tool. Why I am mentioning about tool is, normally when we do analytics, we will be involving or we will be making use of various tools for the purpose of doing such analysis. So, when we are depending on a tool, the tool has been developed for a specific purpose. Therefore, the data that we feed into the tool will be analyzed with respect to that purpose for which the tool has been developed. So, that is the reason why data analytics is distinguished from traditional data mining by means of the scope, the purpose and focus of the analysis. When we talk about data mining, normally data miners, what they do is they take the data, they run through the data or scan through the data for the purpose of identifying undiscovered patterns and establish hidden relationships. So, when we are dealing with respect to a data mining, in data mining also we are actually dealing with a vast data set. The size of data with which we are actually dealing does not matter here. Fundamentally, in data mining we are going to deal with a very large data set only. In data analytics also we are going to deal with a very large data set. So, therefore, we cannot provide a clear distinction with respect to data mining and data analysis or analytics with respect to the volume of data which is handled. So, what makes the difference is, data analytics actually focuses on inferences, the process of deriving a conclusion which is completely based on the knowledge which a researcher has. So, fundamentally we are going to deal only with respect to the inferences that we are going to make. Now, what exactly you mean by it? Whenever we run any analysis, of course, we will end up with various patterns. These patterns might highlight certain scenario. Now, the purpose behind these scenarios can be recognized only when we apply this in a decision making environment, especially in a business. For example, I identify a pattern, say purchase of an item A implies purchase of another item B. Now, this might be a pattern which is a result of applying any data mining technique. Now, what is so nice about this particular pattern and why do we require this pattern? And this is the place where data analytics differ from data mining. So, data mining provides you the patterns, but data analytics exactly helps you to infer and then use the inference for the purpose of improving the knowledge. So, data analytics and data mining though seem to be similar, but they are completely different in terms of how it is being taken into account for the purpose of analysis. Many of us might have heard about a term called big data, and big data is the recent buzzword in the industry as well as among the researchers. Now, what exactly you mean by big data? Why it is closely associated with data analytics? I already told you, data analytics and data mining are actually dealing with voluminous data. Now, when we are dealing with a very large data set, then we call that to be a big data. So, big data analytics fundamentally refers to collection of data, organizing the data, analyzing very large sets of this data, that is what we actually called as big data, to discover patterns and other useful information. So, in big data analytics, what exactly we are trying to do is, we are trying to involve ourselves into a process with which we collect, organize and then we analyze. That is the reason why the terminology big data is closely related with data analytics. In the next part of this lecture, we will be dealing with what is big data, what is its impact on data analytics and where all we can apply big data. As I already mentioned, big data is a buzzword and big data is perceived in a different way by different people as well as by different organizations. Many people across the globe have recently identified that big data is going to be an important player in say the market, as well as data analytics is going to be a key process that will improve the business thinking. That is the reason why big data is considered to be very important. So, what people are trying to say here is people have identified that big data analytics gets bigger and hotter, and this was identified in 2012 and it was published in InfoWorld in 2011. Sometimes people say big data is science microscope of the 21st century, and this is one phrase that has been published in Business Week in the year 2011. Decision making is an important process in business, and people have identified that big data is going to create a great impact in decision making process, and this was published in the year 2012 in Financial Times. So, the term analytics has been used by many people as buzzword to describe quite different functions. Now, where is this big data? Now, when we talk about big data is everywhere. Now, where exactly we can find this big data? One fundamental source where you can have a voluminous data is the web, fundamentally the World Wide Web. Now, what exactly World Wide Web is offering? World Wide Web offers various forms of data, and these data are 4.56 billion pages, and this statistics has been collected from worldwidewebsize.com, and this statistics is the most recent statistics. It has been collected in 2015. So, index web pages contain at least 4.56 billion pages. This is a voluminous data. These 4.56 billion pages actually host various informations, like they have textual data, they have image data, they have audio data, video data, unstructured information, etc., etc. So, when we take web data, we can find lot of differences even in terms of the format and also in terms of the data itself. Actually speaking, when we talk about web data, we should also deal with the users. There are millions of users getting connected to World Wide Web for the purpose of browsing through various information available in the World Wide Web. When we talk about web data, we will also have to think about the dynamism exhibited by the user as well as the data. The data that is available in World Wide Web today need not be available the next day. The size of the web data available today will always increase the next day. Similarly, the users available in the World Wide Web environment today need not be tomorrow. Therefore, lot of dynamism is exhibited in the World Wide Web environment with respect to the data as well as with respect to the user. Now, when we deal with respect to such a voluminous number of web pages and users trying to access these web pages, naturally we are going to end up with a very large data. So, this is one place where we can find big data. The second important place where we can find big data is e-commerce. There are a lot of e-commerce websites available across the globe, and people are making lot of e-commerce transactions across the globe. So, when we are capturing such information, naturally this will be a big data. Let us take for example Flipkart.com. Flipkart.com is one place where online transactions happen many number of times per day basis. So, when we capture the number of transactions happening on per day basis as well as the number of users performing such transactions will be too large, and hence it can be considered to be a big data. Based on the volume alone, we cannot decide it as a big data, but also we should deal with respect to the nature of the data. The nature here in the sense, what are the different formats in which the data is available. So, in Flipkart you can find data like say image data, you can find descriptions about the image data, say for example features exhibited by a mobile phone. So, the mobile phone will be available in the form of an image, and features related with the images will be displayed as textual data. Now, a user has to browse through all this information. Sometimes when the user wants to purchase that particular mobile phone, the user will be taking a look into the ratings provided by different other users who have already purchased or used that particular product. The rating which is offered will be available in the form of an image, say it can be an icon or it can be a textual description which is a posted by user. So, we have textual data, we have image data, sometimes even video data or say animations is also available. So, based on the type of data also we can say it is big in nature. The third place where we can find big data is purchases made at various department and grocery stores, bank credit card transactions, and one important thing on the web is social networks. Social networks is one place where we can find such a huge or voluminous data. Let us take any social network application like Facebook for example, and we can just imagine how many number of users have Facebook login across the globe, and each and every user is going to provide, even if their profile information is provided, that itself will be a very large data. But every user having an account with Facebook is also connected to many other users across the globe. So, when we are dealing with respect to social network applications like Facebook, we will be ending up with voluminous data. Next important source of big data is sensor networks. In the recent days, you might have seen application of sensor networks in various domain, especially healthcare as well as in natural calamities monitoring and firefighting environments. In such environments, we can find huge number of sensors transmitting data at different points of time. Now, when we deal with respect to all these applications or all these scenarios, the first thing we have dealt is with respect to the size of the data. The second thing is with respect to say the different varieties of formats, and the third thing that might come into picture with respect to the last two applications which we discussed like the social networks and sensor data is the velocity at which the data comes into picture, that is the rate at which the data comes into picture. So, sensors when they are transmitting data for example every second, then just imagine in one day how many number of data will be there, and for a year it will be very large, and for say 5 or 10 years it will be very large. So, these are all certain sources where you can find big data. So, to start with a very simple example and to understand what exactly is big data, just ask these questions to yourself. What is the maximum file size you have dealt so far? From my perspective, I have downloaded various files which are movie files from various websites, and these movie files at the maximum I have dealt with say 5 GB. This is an approximate answer. Now, as an individual I am dealing with 5 GB of data. There may be many other individuals who are connected online might also be dealing with such 5 GB of data. So, just imagine what will be the size of data which is accessed by all the users connected online. The next question is, what is the maximum download speed you get? I have got an internet connection with 20 Mbps speed. Now, what is that I can do is I can download various information. So, the maximum speed which I have encountered is say for example 2 Mbps. So, with 2 Mbps data that is streamed down, when I want to do an analysis, it is practically not possible. The reason is for a particular second, just imagine there will be 2 Mbps of data. So, this is very large, and when we are going to deal with respect to say a whole day, the size of the data will be very voluminous. The third simple question that we can ask to ourselves is, what computation has happened? For example, how much time to just transfer the data? When I am uploading certain files, it will take certain time for uploading the data. So, what is the maximum time taken, or how much time did I spend towards uploading a data? So, all these questions, when you get an answer, you can imagine what will be the size of data we are actually dealing in the real world. Actually speaking, for a normal individual, for any average individual, 640 KB of data is enough, but practically speaking the amount of data that we deal is very large than 640. The reason is we will not be concentrating on just the 640 KB of data. We will be trying to cover as much data as possible that is available on the web or from any data source. That is the reason why we are not dealing with just 640 of KB of data per day basis. Now, the table given here will provide you an idea of the memory units, the corresponding size in bytes and their binary size. So, we have kilobytes of data represented by 10 to the power of 3, megabytes in terms of 10 to the power of 6 bytes, gigabytes, terabytes, petabytes exabytes, zettabytes and yottabyte. Yottabyte is 10 to the power of 24 bytes. Now, why I am introducing all these memory units is we will be dealing with voluminous data. So, the data that we are going to handle in any data analytic environment, or when we call something as a big data, it must have very large data set. So, we must be in a position to clearly understand the units that might represent very large data. So, how much of data is available? First, let us take the example Internet Archive. Internet Archive is a non-profit organization which is trying to collect various information about the web pages available over the World Wide Web. So, they have indexed approximately 15 petabytes of data, and this is a statistics that is collected on May 2014. So, 15 petabytes is 10 to the power of 15. So, 10 to the power of 15 bytes of data multiplied by 15, that is 15 petabytes of information. Now, with respect to Google, Google is one of the largest search engine giant. Google encounters lot of query streams and it has to provide answers to those queries. So, when we are talking with respect to Google, Google actually processes 30 petabyte of data on a daily basis, and this information has been published in an article titled MapReduce in portal.acm.org. And even you can find lot of other information available on the World Wide Web talking about the size of Google server, how much amount of data they process on a daily basis, which can be always found in the World Wide Web. AT&T Bell Laboratory actually transfers about 30 petabytes of data through its network each day. So, this is published in AT&T Newsroom, and one important project which is German Climate Computing Center, and this center has been created for the purpose of monitoring changes in terms of weather. So, various weather parameters have been monitored and these parameters are saved in the form of data in their weather server. So, this German Climate Computing Center has a storage capacity of 60 petabytes of climate data. So, when we want to do a real analysis on climate data, then we will have to deal with 60 petabytes of climate data. Wayback Machine is another entity that is closely associated with Internet Archive. So, originally Wayback Machine was actually used. So, Wayback Machine is actually a name provided for, say, the indexer that crawls through various web pages and index them. So, this Wayback Machine has 3 petabytes and it processes 100 terabytes per month. The next important domain where we can find voluminous data, as I already mentioned, is Facebook. Facebook has 2.5 petabyte of user data and it processes approximately 15 terabytes on a daily basis. Normally in a Facebook, whenever we upload an image or whenever we are changing our profile picture, what Facebook does is Facebook will save that image in as 4 images. So, when we are uploading one image, it is transformed into 4 images. Now, in 2013, that is on January 2013, in Facebook, users have uploaded approximately 240 billion photos. Now, each of these photos will be transformed into 4 other images. So, totally 960 billion images were there in Facebook environment, and the size of these images, 960 billion images, is estimated to be 357 petabytes of storage. So, now you can imagine what is a big data and what is its volume. eBay is another e-commerce giant which has 6.5 petabytes of user data and it is processing 50 terabytes per day. Now, when we talk about eBay, eBay actually deals with various user transactions, user login information, customer preferences, customer wish list, then the various products which has been viewed by various customers, all this information put together will be dealt by eBay. So, what exactly it has to do is, it has to keep track of various users and their preferences, and according to their preferences, it has to provide recommendations. Now, for example, assume I am going to purchase a product in eBay, and the product that I am going to purchase is, say, for example, a particular tab. Now, when I type the query tab, automatically eBay must suggest me what are the possible products that are related to my search query. So, now eBay will be recommending me various products which are nothing but tabs. Now, when we take a look at those information, it will provide a clear picture of all those products. Now, when I select a particular product, eBay automatically has to recommend me alternate products or products that might go hand in hand with the tabs. So, in the eBay page itself, you can find other list of products that are interrelated to the product which I am currently viewing. So, what exactly eBay is trying to do is, eBay is trying to capture the user preferences through the various transactions that has been performed by users across the globe. Now, these preferences need to be saved, processed, and then the recommendations need to be provided to other users. I am not the only user connected to eBay. There are millions and millions of users are connected to eBay. Therefore, to all those million users, recommendations need to be provided. Just imagine what will be the size of computing, what will be the size of data which eBay has to make use for providing such recommendations. The next important place where you can find big data is CERN's, or a place where you can generate big data is CERN's Large Hadron Collider, LHC. This CERN's Large Hadron Collider actually generates 30 petabytes of data a year. We will be discussing about what exactly this Large Hadron Collider is generating, what type of data it is in the forthcoming slides. The movie Avatar is reported to have taken over 1 petabyte of local storage for the purpose of rendering 3D CGI effects. So, for any animated movie, normally we need to have more amount of data or voluminous data for the purpose of effective rendering. So, whenever we involve any rendering process, the size of data that we are going to deal will be volume. Teradata Incorporation in its database has a capacity of 50 petabytes of compressed data. So, now I have provided you examples like Wayback Machine, Facebook, Internet Archive, Google, AT&T, German Climate Computing Centers, where you can really visualize big data in terms of its volume. So, I told you CERN's Large Hadron Collider. So, this slide you can find a picture of the CERN's Large Hadron Collider. So, this picture has been taken from the home page of CERN's website. Now, why we are talking about this CERN's Large Hadron Collider is, there is lot of computation happening in the CERN's laboratory. Now, in the CERN's Large Hadron Collider, approximately 600 million times per second particle collision is happening. This is per second. Just imagine in 1 hour how many number of collisions will be there. Now, all these collision information need to be captured. So, we have lot of electronic circuits that will record and send the data to the CERN data center. So, in CERN's data center, 30 petabytes of data are produced annually. The data center actually processes about 1 petabyte of data every day, which is equivalent to 2,10,000 DVDs. The center actually hosts 11,000 servers and 1 lakh processor core. Now, this example will help you to clearly visualize how exactly a big data is. And now, when you want to do an analysis, this is what is real data analytics. Another example where we can find voluminous data is Earthscope. Earthscope is world's largest science project which has been dedicated for tracking North America's geological evolution. So, various sensors has been deployed across various parts of North America. These sensors actually transmit data which will be weather information as well as other geographical data. Such geographical data are saved in the server, and that size is approximately going to be 67 terabytes of data. So, now when we want to run an analysis, we need to analyze on 67 terabytes of data. So, this volume itself will provide you an idea of what exactly is big data. Now, when we are talking about big data, I also told you the type or the structure or the format of the data will also vary. So, what are the various types of data that will be dealt? So, we can find relational data in the real world. So, we have tables, transaction, legacy data. Then we have text data from the World Wide Web. We have semi structured data like XML. Then we have graph data which is taken from social network as well as semantic web RDF structures. we have streaming data. In streaming data we can only watch, and when we want to do an analysis it is highly impossible. So, these are the wide variety of data that is available across the globe. Now, let us take few examples and domains where we can find many forms of big data. Let us take banking domain. In banking domain we have data in the form of video, image, audio as well as text. The shades over here highlight what is the volume of the particular type of data. For example, in banking, text or numbers is darkly shaded, meaning text or numbers is available in large in a banking domain. Next comes video, image and audio, since they have the same shade. Let us take another domain, say a retail domain. In retail domain, normally we deal with text data and we deal with video data. So, text data is available in large, and next large available form of data is video data when compared with image and audio data. Image and audio data are lightly shaded, therefore, it means image and audio data are available low in terms of its volume. Take for example, education domain. In education domain we deal with video that highlight various video lectures, then we deal with audio associated with those video lectures, and also we deal with textual data and image data. But practically speaking, when we talk with respect to an education and when we want to improve education, we need to have lot of multimedia content. So, we will be having more amount of video and audio in an educational domain rather than image and textual data. Likewise, you can just have a look at the various domains and you can find what is the level of data associated with various types of these data. So, having understood and got a complete picture about big data, now let us define what is a big data. There are various definitions associated with big data, but two definitions have been accepted worldwide. One definition is big data actually exceeds the reach of commonly used hardware environment and software tools to capture, manage and process. This definition is provided by Merv Adrian in Teradata magazine article. So, what exactly this definition says is the big data exceeds the commonly used hardware environment and software tools. What do you mean by it? Normally available or traditionally available hardware and software tools cannot handle the data. This is what you mean by big data. The second definition is big data refers to data sets whose size is beyond the ability of typical database software tools for the purpose of capturing, for the purpose of storing, managing and analyzing, and this is a definition which is published in McKinsey Global Institute Big Data article in 2011. So, these two definitions actually highlight the fact that traditional hardware and software environment are not capable enough in terms of handling a voluminous data. So, that is what big data is trying to highlight. Now, when we want to understand big data more clearly, then we will have to identify the characteristic features of big data and understand them. So, big data is associated with 4 important characteristic features or 4 V's, famously called as 4 V's. So, the first V is volume, the second V is velocity, the third V is variety and fourth V is veracity. What exactly we mean by volume is the size, it deals with respect to the size. Velocity is the rate at which the data is captured. Variety is the different types of formats, and veracity is fundamentally the uncertainty associated with the data. Now, let us discuss about these 4 V's in detail. First, let us take the first V, volume. Volume, as already I have mentioned, is associated with the quantum of data which is being handled. For example, 2.5 quintillion bytes of data is created on each day. 2.5 quintillion of data is created on each day, and on a daily basis, if this happens, then the size of the volume that is generated over a period of month or over a period of year will be very, very voluminous. Many organizations across the globe are dealing with such voluminous data. They already have lot of such data that actually highlights the volume. The second V is velocity. Let us take for example, the car that we are traveling currently with. car normally has more than 100 sensors, and all these sensors are going to transmit information or data at different points of time. Now, the rate at which the data comes to say a particular point where we want to make a decision or where we want to make an analysis is actually very high. So, the rate at which the data actually comes into picture in the real world is very high. So, this is what we mean by velocity. The third V is variety. We can take various examples from the World Wide Web environment, especially from social network environment. When we take even a Facebook application, in Facebook application we can find variety of data. For example, we have images, we have video information uploaded, we have animations uploaded, and the various comments posted by the user are going to be textual data. So, this is a best example for variety exhibited by big data. The last V is veracity. Veracity is fundamentally uncertainty related with the data. Why there is uncertainty is when we are dealing or collecting raw data from the real world environment. In the initial state of this, but in the initial part of this particular session, I mentioned the raw data that we collect basically has lot of unclean information or unclean data. So, sometimes these unclean information might result in bad decision making process. So, we need to handle such unclean data, process them, and then convert the unclean data into a quality data. So, uncertainty exhibited by big data need to be handled effectively such a way we can make good decisions. So, veracity is fundamentally the uncertainty that is exhibited by the raw data which is collected for the purpose of analysis. This slide actually highlights the various application domains where we can make use of big data and analytics. So, here you can find real estate and healthcare are two important domains where big data plays a vital role. Similarly, manufacturing, transportation, finance and insurance, management of companies, educational services, administration, support and waste management are other domains where this big data and data analytics can be widely applied. So, this picture clearly shows the scope for research as well as the scope for development of various tools towards analytics. Having understood what is data analytics, what is big data, now the next question which must arise is which one should we give importance? Is it the big part or the data part or both or neither? So, the answer is it is not the big part, it is not the data part, nor it is even both part. We must not deal either with big or the data, and what else we need to analyze or understand or we should worry about is it is only about the outcome. So, when we are dealing with respect to a big data, what exactly we need to worry about is we need to worry about the inferences that we make out of the analysis. So, when we perform an analysis, we end up with results. These results highlight various patterns. Now, what is the use of these patterns? Where it can be applied? That is the place where exactly big data and data analytics must focus on. Only then effective decision making can happen and improvement in terms of a business growth will be occurring when we are adapting big data and data analytics in business domain. Now, how big data is different? Big data is different by means of various ways. One fundamental thing is it is automatically collected by machine. The second thing is big data is typically new because it is collected from different data sources. Big data is not designed to be user friendly, it can be messy and ugly, and still now we do not have any standard. These are the various features that make big data different from traditional data that is available in any data sources. Now, let me summarize the various facts that we discussed in this lecture session. Initially, we defined what is data analytics, then we understood what is the major difference between data analytics and data mining, followed by definitions of big data. Then we went through various examples with which we could have got a complete picture about big data, the characteristics of big data which is nothing but the 4 V's, and finally, We also discussed about various use cases or applications wherein big data and data analytics can be applied. Thank you.